Hello, and as always, welcome. I'm sure you've noticed I'm not in my usual place today. I'm on location at Laramy-K Optical Lab. And you know, from the outside, it doesn't really look like much. But on the other side of this wall is the knowledge, experience, and technology to produce some of the finest lenses in the world. And I don't say that just because I work here. I say that because it's the truth. And that is what we're going to talk about today. So I'd like to invite you inside and let me show you how it's done. Wholesale optical surfacing labs are where all types of optical lenses are designed and actually created. They are not to be confused with finishing labs. Finishing labs are where they cut down finished lenses to fit a frame and where they assemble eyewear.
Good afternoon, Laramy-K. This is Doreen.
We start our visit here in the customer service department. Every lens begins the same way with the creation of a job order. It is here that the lab will capture all the information necessary to properly design the lens. This includes things you might think about, like lens material, and also things you might not, like frame shape, position of wear measurements, or even a request for a specific edge or center thickness. The better the information gathered during this crucial first step, the better the final lens design will be. In many ways, the most important tool in the creation of a great lens is great communication, and that all begins here in customer service. After the job order has been written up, it will move to an area Laramy-K calls Tray Up and Lens Blank Pull. This is where the job order form will be placed in a barcoded tray. The tray indicating the material that the lens will be made of. Next, a worker will pull the lens blanks necessary to create the lens. In simple terms, a lens blank is optically significant on the front and raw material on the back. The lens blank will be chosen by material, design, like if the job calls for a line bifocal, occupational or single vision, and features like polarized or changeable tint, and the base curve required. Even here, the right blank will be set on the right side of the tray and the left on the left. A medium-sized lab like Laramy-K may stock as many as 10,000 lens blanks. Now that the order has been trayed up and the lens blanks have been pulled, it gets entered into the Lab Management Software System, or LMS. Depending on the lens design, the system may require entering 50 data points or more. Once entered into the LMS, this job can now be tracked through each lab station, and in some cases even relay real-time status to customers. Now the data entry is complete, the tray moves over one station where it is verified for accuracy. The tray's barcode is scanned, the job is pulled up in the LMS, and reviewed for material, style, blanks, and matching paperwork and tray. Once verified, the lens blanks are removed from their box, unwrapped, and marked R for right and L for left. This is an important step since it is rare that the blanks are the same for the right and left eye. As you will see in just a few minutes, we are about to literally grind away the back side of the lens blank to create the curves necessary to fill the powers that match the prescription ordered. That grinding process requires a lot of force, heat, and motion. Blocks are what hold the lens blanks firmly in place. Here, the tray's barcode is scanned again so that the LMS can pull the job parameters up for the operator. This information will tell the operator which type of blocking procedure to use. The first step is to protect the front surface of the lens. Tape that is designed specifically for the blocking process is stretched across and then vacuum pressed in place for excellent wrinkle-free adhesion. Blocks will vary by the lens blank front base curve and by the machine that will be used to surface it. The operator will now choose the appropriate block style and load it, along with a special ring that helps position it, into the blocker. The screen she is watching shows her precisely the proper placement of the lens blank in relation to the block. The adhesive used to hold the block to the lens will be either a lead alloy or wax. At Laramy-K, lead alloy is used for lenses headed to the FREEFORM surfacing line, while wax is used for conventional surfacing. Both are heated to their melting point so they become liquid. Here, you can actually see the lead alloy filling the void between the block and the lens. The melted alloy is then cooled by water being pumped through the sleeve that surrounds the block. As the alloy cools and hardens, it adheres to both the lens and the block, creating a bond able to withstand the forces of the surfacing process. This lens is now blocked and ready for surfacing. Notice how thick the lens appears? The lens blank must be thick enough to allow us to grind away the back surface to create the curve or curves necessary to create the prescription ordered. Notice how the block is designed with cutouts or holes so that it can only be loaded in a single position. We are about to grind curves that must remain in the exact same position throughout the rest of the process. These blocks will remain attached to the lens for another 2 or 3 steps. After blocking, the tray is going to move down one of our 2 lines, either the conventional line or our freeform. Let's take a look at the conventional line first. We'll save the best for last. The lab may run simple single vision jobs and very basic multifocals on conventional equipment. These are jobs that would not benefit from the complexity of freeform design. We also turn to conventional surfacing when a job falls outside the range that freeform generators can handle. The tray's barcode is scanned into the system, and the job order is pulled up on the screen. The lens is pulled from the tray, chucked in the machine, and the process begins. This is a conventional surface generator creating a lens. It is literally grinding away the back surface of the lens, creating curves that provide the power necessary to fill the order. It may not seem like it, but the tool cutting the lens back surface is actually moving in fairly simple patterns. When we get over to freeform, you will notice that the hardware is actually much the same. It is the ability of the tool to move and cut in complex patterns that makes the difference. Believe it or not, that lens is already done. The back surface of a lens coming off a conventional generator looks like this. If you look closely, you can see the actual pattern of the cutting tool and the ridges that it leaves behind. For a lens coming off the conventional generator, bringing the lens to full, clear, perfect optical quality is a 3-step process. First, a worker will pull a convex tool that will perfectly match the concave back surface of that lens that we just created. These tools, called laps, which are accurate to within 6/100ths of a diopter, need to match the curve that creates the spherical power and the cylinder power. Laramy-K stocks about 6,000 lap tools and can create a tool for any power that can be run. Here is a special tool created by hand to fine and polish a lens with 21 diopters of cylinder. The second step is called fining. Fining is done in these cylinder machines. The lap tool, with a mild abrasive pad attached, is loaded into the machine. The lens is then loaded above the tool and a flow of water is started. Then the lens is pressed against the pad for a set pressure and time. The unique pattern of motion the cylinder machine uses assures that the lens will remain on power. The third step is called polishing and works the same as fining. The abrasive pad is swapped out for a soft one, and a slurry of polishing compound flows across the lens instead of plain water. Once complete, the lens is now perfectly clear. Now let's hop on over to the FREEFORM line. As I just mentioned, the process here is not really much different than that over on the conventional line. It is in the software-hardware interface where the magic happens. The tray is scanned and the job appears on screen. The lens being shown was designed by advanced software. This design is not conventional in that the tool cutting the back surface of the lens can move in virtually all planes and positions. The surface that it is creating is not based on two axes, but an infinite range of possibilities designed to best fill the lens order. Just like on the conventional side, the lens is chucked, and then a diamond stylus cuts the back of the lens. The FREEFORM generator cuts the lens wet, and the coolant spray makes it a little hard to see. Once the lens is done, it is removed and the back surface looks like this. Because the FREEFORM generator can create a much smoother cut surface, a lens goes directly to a polish cycle in this updated version of a cylinder machine. Because the back surface of the lens is fluid in shape, no tool exists that could match it. Instead, the polishing pad is pressed against the lens, and the flow of polishing compound is begun. In just one step, in a few minutes, the lens is perfectly clear. All progressives and some specialty work will now move here for their laser engraving marks. Lenses are loaded in the machine, and behind that shield, a laser etches the lens surface with the invisible markings that tell us about the progressive lens design. As an independent lab, Laramy-K can do custom engravings to match any house brands. At the FREEFORM line, the blocks and lenses are heated in near boiling water to soften the alloy and break the adhesion between the lens and block. A quick brush removes any remaining alloy, and the blocks are then ready to start the process over again. A worker removes the protective tape applied at blocking, and the lens is moved to the station, cleaning, and first inspection. Here, the FREEFORM lenses will meet up with those off the conventional line that use the wax. A short shot of air pressure breaks the bond, and then any remaining wax is melted away in this tool that contains hot, soapy water. Once clean, the blocks are ready for reuse. Now surfaced, fined, polished, and deblocked, these are complete optical lenses about to get their first inspection. As you have just seen, the surfacing process is far from gentle. The inspector has a keen eye for common problems that might occur during the process. If a job requires tinting, that would be performed next. This is the tint station. Each lens material requires its own tinting techniques, and the operator must monitor temperatures and time for each individual tint pot. As you probably know, tints come in many colors and may be applied in different patterns. Depending on the job order, some lenses will now have a scratch-resistant spin coating applied, while others will move on to the coating lab. Here, lenses are loaded into the spin coating application machine, and, just like it sounds, the lenses are spun while a special coating is sprayed on the surface. The coating is UV cured, so they remain behind the shield to protect the worker from harm. After surfacing, the lenses will come here to the AR lab. Just like surfacing, AR is a multi-step process, but one that takes quite a bit longer. The coating lab is a freestanding room within the lab that is operated much like a clean room or operating room. Here, Laramy-K applies anti-reflective or AR coatings, flash mirror coatings, and selective blue blocking coatings too. Start to finish under the best of circumstances, the application process for a premium AR takes roughly 5 hours to complete. It is important to mention that 5 hours is a best case scenario. That 5 hours cannot be rushed, changed, or shortcut in any way. Once again, the tray is scanned and everything is double-checked for accuracy. Each individual lens now gets a thorough visual inspection, cleaning, and gets suspended in a hanger. The hanger is placed in a basket, and the basket then goes through a 4-step pre-wash designed to remove any surface contamination. The steps are pre-soak, soap, sponge, rinse, and the process takes about 8 minutes. Next, each lens receives a thermal hard coat or thermal cured scratch resistant coating. This is a 10-step process that requires about 28 minutes. The steps are etch, spray, bath, dryer, activator, activator cure, foundation application, and pre-cure. The lenses will now be inspected for any flaws in the thermal coat process and then move into the final curing rack where they will remain for 2 full hours. After the thermal hard coat is cured, each lens must be re-ringed to match the equipment in the next phase. These rings are the ones that will hold the lens in place in the collet within the actual application chamber. Once ringed up, the lenses will go through another preparation process similar to the pre-wash. This will etch the hard coat so the AR layers have something to hold on to. This pre-wash takes about 8 minutes. After pre-wash, the lenses go for degassing or drying in an oven for 1 full hour. The last step before entering the application chamber is a final inspection in the flow booth. The flow booth blows filtered compressed air across both surfaces of the lens, and minute particles of debris can still be safely removed with careful use of a sterile cotton swab. As each lens passes inspection, it is loaded onto the collet. The collet is loaded into the application unit along with a tray of compounds that correspond to the layers of the AR stack. A vacuum is created inside the chamber, and an electron beam vaporizes the compounds at temperatures that can reach 2,000 degrees Celsius. The vacuum in the chamber ensures the extremely high temperatures are not transferred to the lenses. The vaporized compounds are deposited, one at a time, on the surface of the lenses, creating the layers of the AR stack. The first round requires 27 minutes per side, or 54 minutes to complete. The chamber is then reopened, and a new set of compounds are added to create the hydrophobic and no-slip powder coat layers. This requires 10 minutes per side, or an additional 20 minutes of process time. Once that is complete, the lenses can be removed, visually inspected, and then sent off to final inspection. Just like it sounds, final inspection is the true final determination of whether a lens meets standards. Laramy-K uses a proprietary set of standards that are far more rigid than ANSI. As Janet, the president of the company, says, ANSI is for amateurs. For all work that is not freeform, the process is about the same as it has been for the last 100 years or more. An experienced technician uses a manual lens meter and inspects the work for power, checks the lens one more time for any surface quality issues, and double checks that any special customer requests, like a specific edge or center thickness, have been met. Some lenses are verified using an auto lens meter, which makes the job a little quicker and easier. Now, here comes the really important part. When it comes to freeform work, Laramy-K employs a dual lens mapper. Comparing a lens meter to a dual lens mapper is kind of like comparing a rotary dial phone to your smartphone. Every freeform lens design is a theoretical model. The dual lens mapper allows us to compare how close we are to matching that perfect model. The closer we are to the perfect model, the closer we are to the perfect lens. The dual lens mapper is creating a three-dimensional model of the lens, which can be examined layer by layer. It can even model the entire spherical portion of the lens independent of the cylinder and vice versa. When properly understood, the data from the dual lens mapper can alert us to maintenance issues 1,000 jobs before it would ever be noticed in a manual or even a high-end auto lens meter. The trays leave final inspection and go on to packaging. Here, the lenses and paperwork will be reviewed and paperwork separated into our files and customer records. Each lens is carefully placed in a protective sleeve, wrapped in its paperwork or job order, and rubber banded closed. Finished lenses are now placed in a customer holding area, awaiting any other jobs for them that might be due out of processing before the end of the day. Shortly after production shutdown, the actual shipping process begins. Here, workers carefully prepare packages for shipping with UPS or FedEx. And speaking of UPS, there go our lenses to continue on their journey to one of our customers and then ultimately to one of theirs.